Okay, looks like it's time. Hello, everyone. I'm Andrey Breslav, and we're starting our webinar on Kotlin 1.3. Today, we are co-presenting with Roman Yelizarev. I'll give a short introduction now, then hand over to Roman to speak about Coroutines, and then I'll come back for a Q&A session. So you probably know that we released 1.3 not so long ago, and it's been a very interesting release. Many people, I'll give an overview of how our core principles are realized in this release and what we pursue with what we're doing there. Kotlin is known to be a pragmatic language. This has been our motto since the very beginning. And here is how the idea of pragmatism unfolds for us. So basically, what a language is, how we see what a language is a tool for turning human thought into working software. And this is the problem we are addressing. This is why we're doing Kotlin, to help people transform their ideas, their thoughts into something that's a working program. And working on this, we have principles that are guiding us in general, and they are realized in 1.3. And often these principles are kind of misrepresented, so I want to clarify them a little bit. Many people think that an important thing about Kotlin is that it's concise. Well, actually, this is not what we're looking for. What we really care about is not concision, it's not the fewest characters we can express some idea with, but readability. We want the code to be clear because we read a lot more code than we write. So it's important that the code is readable, and of course, cluttered code base with a lot of boilerplates, so on and so forth, is not helping readability. So some degree of concision is needed there, but our actual goal is readable code. Same goes for expressiveness. Many languages are proud for being expressive, and this is not a goal for Kotlin. What we actually care about is how much we can reuse the code that we write in Kotlin. And there, of course, we need some abstraction mechanisms that bring expressivity. But what we actually care about is to enable you to take some repeating concept, some pattern that occurs in your code, and abstract it into a library. This is why we have some degree of expressivity, and this is what we care about, code reuse. And another misconception, I would say, about what's good about a language is originality. Like, we tend to boast about having invented something, and this is not a goal for Kotlin at all. So what we actually care about is quite the opposite, is interoperability. So we don't want to stand out. We want to blend in as much as we can. And this is a broader sense of reuse. We want to enable reuse of the existing ecosystems to leverage all the, well, or as much of existing knowledge and code that is out there. And the last but not least, here is soundness. Soundness is a very important property of a language from a mathematical standpoint. But what we care about in Kotlin is safety and tooling. Being sound is just a way of implementing this. What we care about is catching your bugs as early as possible in a convenient way without cluttering your code, without having you struggle with the compiler. And of course, we want the tools to understand your programs as well as they can to help you refactor reliably, find usages, navigate code, so on and so forth. So this is the set of actual goals that we have. And 1.3 contributes to these goals in many ways. I'll give some highlights, very, very high-level things. And we'll give some details on particular topics later. So, but first of all, I would like to tell you about where we are now and what kind of momentum Kotlin has at the moment. This is the graph for our yearly usage. People who opened their IDEs and edited Kotlin code per year. And I'm really, really happy about the growth that we have. A couple of months ago at KotlinConf, I was talking about 1.5 million users 2018, but now we have reached 2 million, which is a very, very happy moment for me. So this is where we are. It's a lot of people, it's a lot of responsibility, it's a lot of opportunity because this community is creating great things together. And of course, this is not happening in the vacuum. There is a job market for Kotlin, and here is our growth curve. Thanks to dice.com for providing the data. So you can see that being a Kotlin programmer today is a very good thing. There is a growing market. You'll be in high demand. So if you're considering learning Kotlin, it's a very good idea. But coming back to 1.3, this release brings a lot of things. But there is a number of things I would like to highlight. And first, and probably the biggest, is what we do for scalability. You've probably heard of Coroutines before, and we'll have an entire big section of the webinar today. But the biggest idea behind adding a new paradigm of asynchronous programming to the language is enabling scalability for the modern world. We want to enable people to write code the way it should scale for our contemporary applications. So the big news is not introduction of the coroutines because they have been around for a while, but the graduation from the experimental status to actual stable. So if you are not using coroutines yet, please go ahead and use them now. It's stable. Everybody should do this. And Roman will give you a lot more details on this topic a little later. Another thing, very big news, we've been working on Kotlin Native for quite a while now. And 1.3 ships with a beta version of this backend. Kotlin Native enables a compilation of Kotlin programs to standalone native binaries, which means that you can run without a virtual machine on multitude of platforms, iOS, Android, with MDK, Windows, Linux, Mac OS, anything you like, including WebAssembly. So there is a lot of opportunity behind Kotlin Native. It's going to grow. It will develop huge and interesting things there. So watch it. And we'll have a separate webinar on Kotlin Native pretty soon. I'll have an announcement at the end of my slide deck. Another thing is that Kotlin Native is hugely interoperable. We are sticking to our principle of interoperability on the platforms we're working on. And for the JVM, it's Java interoperability. For Kotlin Native, it's C, Objective-C, and Swift. So you can use libraries written in these languages from Kotlin Native more or less transparently, which enables everything that the platforms give you right there inside the Kotlin program. An important thing I would like to highlight is that Kotlin Native is not really the same as multi-platform, although many people tend to mix the two. I'll try to explain very quickly what the difference is. So Kotlin Native gives you an opportunity to take a program written in Kotlin specifically for platform X, say iOS or Linux, and here is your Linux targeted program written in Kotlin. You can compile it with Kotlin Native, get a native binary, and run it. But to share the same code, compile the same source for different platforms, albeit different native platforms, or say Windows and JVM or JavaScript, you need something more. It's not just a single compiler. You need a way to abstract platform dependencies and somehow write common code that can be compiled everywhere. So this is what Kotlin Multiplatform is. And today you can have common code that can be run, compiled for and run on the server, Android phones, iOS phones, and in the browser. Through the multi-platform capabilities, there is a special built DSL for Gradle. There is an entire tool chain that supports this. There is the tooling in the IDE. So a lot of things can be done and reused across different platforms using Kotlin Multiplatform. There will be details about this in the second webinar as well. A big part of this is multi-platform libraries, because just providing you a tool chain is a start, but then when you write common code, you need to rely on something being already there. And we started building an entire platform for multi-platform development, which is obviously HTTP serialization, logging, settings, and the coroutine management facilities. These are like very basic blocks. We'll be working on many more interesting things there, but these are already available as multi-platform libraries. So this is more or less the highlight of what 1.3 brings to you, and I'll give you a very, very quick overview of what our evolution looks like, what we're looking forward to in the next releases. There are three main principles that drive Kotlin's evolution. We started as a modern language. We wanted to advance the standard in the mainstream languages. So we started from scratch and didn't iterate on an existing language design just to get rid of the legacy. And this is something we want to preserve. We want to keep the language modern. And this is the first principle. So we'll be getting rid of legacy as we accumulate it, because we understand that all the ideas are alive, they age, sometimes they don't age well, we need to phase them out. So we'll be working on getting rid of the legacy that we accumulate over time. But this idea is very much constrained with the second principle of comfortable updates. We can't simply say, okay, this idea is bad, we'll just throw it away and break all the existing code. We don't do this. What we do is very, very slowly, gradually prepare the world for phasing something out through deprecations, through automated migration tools, so that when we actually get rid of a legacy feature, it's not really used anywhere anymore. And the third principle is the feedback loop. So when we introduce something new or change something old, we want your feedback first and foremost. And this is why we have preview builds, experimental features, and why we design in the open and do all these things to understand what you find interesting, what addresses the needs of users, so on and so forth. These three principles combined give us the sense of being up to date and being relevant. This is what we actually want Kotlin to be. And speaking of the main priorities for next releases, we'll be doing a lot of cleanup. We've been moving very fast over the last 3 years. Many people told us that it's time to slow down. I'm not going to say we are actually slowing down too much, but we are probably shifting our focus a little bit into polishing things and making things smoother. We'll be doing a lot of technical debt collection inside the compiler and reworking the compiler to expose a real API, which is a great change, and also work on improving and gradiating some experimental features, working on performance, user experience quality, so on and so forth. Here is the end of my very short introduction. I wish you to have a nice Kotlin, and hand it over to Roman to tell you about coroutines. Thank you very much. I'll be taking all the questions that are not coroutines related and are not very specific. The specific ones will be answered right there on Twitter or in the channel. So my first question here is why there is no C++ interop in Kotlin Native, or at least this is what I inferred from the question in the YouTube stream. So Kotlin Native has interop with C and Objective-C, and it interops with Swift through Objective-C. Interop is a whole different story, because C++ is an interesting language that doesn't have an ABI. So interop there is a huge challenge, And I do not anticipate having any interop with C++ in any foreseeable future. Although if someone comes up with a brilliant idea of how to do it, it's not completely impossible. I hope this answers this question. And also you can oftentimes interop with C++ through C interop, which is kind of a lingua franca of native world. Next question is about WebAssembly. It reads, WebAssembly codegen supports, is supported in Kotlin Native, and memory management compatibility between Kotlin Native and WebAssembly runtimes is there. So possibilities of convergence with Kotlin.js in the future. So this is actually a pretty complicated story because WebAssembly is a moving target at the moment. So it's very like early origin, although I'm not sure that WebAssembly developers will agree with this, but at least the topic of having something other than a JavaScript for the browser started with Asm.js, and this is an unmanaged runtime, basically. It has linear memory with no object runtime built in, and this is what WebAssembly is today. So we can run Kotlin Native on it because Kotlin Native manages its own memory. But then there is the next chapter of this story, WebAssembly coming up with very needed GC support and JavaScript interop support. And this brings an object runtime into the WebAssembly picture. So it's a completely different story. So Kotlin Native doesn't fit there so easily anymore. So if you're using the WebAssembly GC for interop with JavaScript, if you want to use the browser APIs and so on and so forth, then Kotlin Native doesn't fit in there, and it's much closer to what we have in Kotlin.js. Simply, well, not simply, but replace the generation of JavaScript by generation of WebAssembly and tweak some things in the interop, and there you are. As for Kotlin Native, it's a completely different story, right? You take your raw memory with no memory management, and you run there. So at worst, there will be two Kotlins for WebAssembly, but I don't think this is going to happen. Most likely, we'll converge in the Kotlin.js-like WebAssembly backend, which will either coexist with Kotlin.js, or if WebAssembly is popular enough, one day will replace Kotlin.js. And it will manage, use the memory management mechanisms of WebAssembly. We're not there yet. There is zero work finished on WebAssembly GC. No browsers support the GC today, so it's a very distant future. And we are watching this process closely. We want to be present in the WebAssembly world, so we'll keep in touch with the WebAssembly team and see what comes out of this. More questions about WebAssembly. Yeah, just wishes that Kotlin becomes big player in that space. Yes, we want that. The premise would be for WebAssembly to actually release something not experimental. We're waiting for that. And I think that's it for WebAssembly. Another question on Kotlin Native. As of 1.3, the only code coverage support from Kotlin is for JVM. LLVM supports different ways of code coverage, but they require compiler support. So can we expect code coverage support in 1.3 updates for JavaScript or native? This isn't on the roadmap at the moment. I'm not sure really if anyone looked into this too closely, but if you really need code coverage tools for your business use case, please come to us, for example, on public Slack or to the issue tracker, and document your use case so that we know what kind of people need this, and we'll be able to prioritize this somehow. Thank you. Next question is about Android. If I wrote an Android JVM library using Kotlin 1.2 and an application using it upgrades to 1.3, could I run into some compatibility issues, excluding experimental features? So our policy is that this shouldn't happen. Binary code shouldn't break between updates. And so if you run into any incompatibilities of this sort, it's a bug. So please report it. And I don't think we have any such bugs reported so far. So my answer is modulo very embarrassing bugs, no. There shouldn't be any incompatibilities there. A follow-up to this question, any things I should know about when writing libraries that could break compatibility? So compatibility is a big thing for Kotlin in many respects. One important thing is how, from the compiler side, we try to maintain the ABI as stable as possible. When we add things, we don't break existing things. When we change things, we make sure that all the ABIs work. So there, in terms of having the same source code and compiling it again and getting ABI compatible binaries, there is nothing you need to do. In terms of writing your library sources so that when you evolve them, the ABI is stable, there is some work that's required on your part. There is some documentation on this on the Kotlin website, but the gist is that you should care about making things public explicitly so that you can keep track of what is actually your API and what isn't. B, you shouldn't use any type inference for return types of public declarations. And this is not so much not so relevant actually for application developers, because this only affects the API. When you have your return type inferred from a body, you can accidentally have a more precise type there. Like it used to be type A, and then you change something in the implementation of this method or some other method, and the type of inference figures out that now it's type B that's subtype of A. From a source standpoint, there is no problem. From the binary standpoint, there is a huge problem. The JVM sees a different signature, and the library won't link at runtime. So to prevent this, just spell out all the public return types explicitly. This is what you need to do to maintain your binary compatibility. Speaking of source compatibility, we also expect you to sensibly name your methods in terms of having overloads do roughly the same thing. Because when some type inference gets smarter, it may select a more specific overload, and if it does a completely different thing, the logic in your program may break. So this is what you can do for your users. I mean, not only from the Kotlin standpoint, but from the sensibility standpoint, your names should be descriptive enough, and overloads should do roughly the same thing. Next question is not directly about Kotlin, but is there a release date for the Parcelize annotation? I believe the Parcelize code is now maintained by somebody outside the Kotlin team, so I can't tell you much about the release date. It's on the Android side now, so sorry, can't say anything about this. Next question. It has a confession. I love inline classes. Would also love to use them in APIs. What is the roadmap to drop the experimental state? Well, before dropping the experimental state, we need to stabilize the current design. Inline classes are pretty tricky. There is a lot to improve about this design, so I can't tell you anything about the dates. We are now looking at the use cases. We've only started using inline classes as a mechanism for unsigned types. We're using them a little here and there in Kotlin APIs. Kotlin libraries are trying to use them in many places. Users outside JetBrains are using them in reporting feedback, so it's a bit early to say anything about when they go stable. This is a big experiment. So another question about inline classes is, can or should inline classes be used in production code? It also refers to coroutines that were experimental for a long time, but was a production quality, and upgrade paths were supplied. So here is roughly the same story. You can use inline classes in your production code. When we change something in the design, we'll try to make your updates as comfortable as possible. No guarantees there, but I expect that things will only require recompilation. So don't use them in public APIs. What the client depends on, because the APIs will change. I mean, the ABIs, binary interfaces, will change. Inside your production code base, when only you depend on it yourself, you can use this feature. The design will be tweaked And yeah, you'll have to migrate, but in the same way as Coroutines did. Next question. What's on the roadmap for improving compiler speed, both JVM and native targets? Compiler speed has been a huge crusade on our part. So the Kotlin compiler can be sped up. And we've been working on this quite a bit. Like every release, we ship significant speed improvements. We keep working on this in many directions. First of all, we are working on a new compiler architecture that should speed things up a lot, but it's pretty hard to tell when this gets ready. Before that, we are improving our incremental compilation. We are optimizing our Gradle infrastructure, which is relevant for Android. We are optimizing the compiler infrastructure in general, which is relevant for everybody. Kotlin Native is working on specific optimizations to speed up the compilation because there is, on top of things common for all Kotlin backends, there is something specific to the workload you put on LLVM. LLVM can require a lot of time to do optimization, so we're trying to feed as little code into it as possible. So yeah, we are doing a lot of work there. There will be updates, hopefully pretty soon. What's the current status and future goal for performance on Kotlin Native? I wonder what to make of it. Since I've told you about the compiler performance, I'll interpret this question in the sense of the generated code. So far, we are doing some basic optimizations in Kotlin Native, and there is a lot more to optimize in the generated code. We are starting to look into this right now. Some things will be reused across different compiler backends. Some things will be specific for Kotlin Native, but overall, the generated code will speed up quite a bit over the next couple of months. Okay, next one. Any info you could share about Kapt incremental annotation processing for Gradle? This is a bit too specific. Oh, no, it's too unspecific. All I can say, we're working on it. We understand it's very important. It's also very tricky. Annotation processing for Kotlin is a miracle. I want everybody to understand this. The fact that Kotlin can support annotation processors written for another language is a miracle. So if we make this work incrementally, it's a double miracle, and we're working on it. Next one is possibilities of support to UFCS. Okay, yeah, so uniform function call syntax. This is something from the D programming language and NIM programming language, pretty exotic. Basically, there are languages that have different approach to, let's say, extension functions than what we have. In Kotlin, you have to specifically declare a function as an extension to be able to call it with a dot after a receiver. D and NIM enable this kind of call on any function that takes any argument. You can simply turn your first argument into receiver. I don't think we're getting this anytime soon. There hasn't been much demand, and this will complicate things quite a bit. So probably not, but if you have a very strong use case, let us know. Next thing, I understand it's too early, but when and where will be the next KotlinConf? The honest answer is we don't know yet. We are examining the options, but hopefully somewhere on planet Earth. Next one, will JetBrains create an IDE for Kotlin specific to Kotlin? It would make quite a nice pair. All right, so currently, this is a product question, right? So if we find that such an IDE serves our users, that like many people will benefit from such an IDE, we'll definitely work on it. So far, it seems that integrating Kotlin support into other IDEs like IntelliJ IDEA makes a little more sense. So we're working on this. Okay, next one. Kotlin's biggest market is Android. Have you thought about the future of Kotlin if Dart Flutter really takes over the mobile web market and Google gets rid of the JVM? Well, of course, if this happens, then there is no more Android, and the world will be very different. So I can't really say what happens then. But I don't think that it's so easy to drop the core component of your entire platform, and a platform with billions of devices, you know? So, well, yeah, I don't believe in this use case, let's say. Yeah. Next thing, Kotlin Multiplatform course that covers JVM Android and native iOS, just like the Kotlin for Java course on Coursera would be great. Yeah, it would. The Android courses are available in different platforms, and there probably will be a one on Coursera as well. And there is another question, when we can expect the Coroutines course on Coursera. This should have been addressed, Roman, I think, but hopefully at some point in the future. Okay, next one. Any ideas for future libraries coming on multi-platform? There are many ideas, like lots of ideas. Some of the library APIs that we have are experimental at the moment, so we'll be stabilizing them. We are working on many things in the realm of networking. So KDOR, the Connected Application Framework that we have, has some components that will be fleshed out over time, like WebSockets, for example, and generic asynchronous I/O, and so on and so forth. We definitely want basic components like file I/O supported multi-platform, or as multi-platform as this is possible. At some point, we need support for things like dates and so on and so forth. Database support at some point, and many, many more things. There are a lot more ideas than a single team can handle. So as much as anyone can help working on your own libraries will be very, very appreciated. Last question on my list, why would Kotlin Native not compete with Go? Why wouldn't it really? It will. I mean, it's definitely addressing similar problems. So I expect Kotlin Native to be a really nice competitor to Go, and we'll see how this unrolls. And I mean, if you try to think of what are pros and cons for these two languages in the realm of microservices, there are many things to compare here. For example, Kotlin has a much more powerful abstraction mechanisms. And as soon as our libraries catch up, there will be a very interesting competition. Go, in its turn, is working on improvements to the language, like they are looking into adding generics. I understand how hard that is, so I'm not giving any predictions there, but yeah, it will be an interesting game. Okay, next one. Will Kotlin have type classes and other functional concepts on language level? Well, I would say I want type classes or some equivalent mechanism in Kotlin one day. It's very hard to tell when this will be ready because we can't add everything at once. But yes, something like type classes would be very, very nice to have in Kotlin. Other functional concepts, not sure what you're talking about. Some are too crazy for any mainstream programming. Some are very useful. We'll be looking into use cases and adding things as they are needed. And I think this concludes my list. So thank you all very much for your attention today. It was great talking to you and answering questions. And have a nice Kotlin. Thanks and goodbye.